Assalamu alaikum. Welcome to our chemistry class. Students, I hope all of you are very fine and safe with your parents and other relatives. Today I am with the important topics of chemistry, which is periodic table. Contents which will be discussed in our today's class are Introduction to Periodic Table, Background of Periodic Table, Dobereiner's Law of Triads, Newlands Law of Octaves, and Mandeleev's Periodic Law. What is periodic table? Do you have any knowledge about periodic table? The periodic table is the organized tabular display of the elements which are arranged by atomic number, electron configurations, and recurring chemical properties following by some periodic laws. The periodic table is the most powerful predictive tool for organizing chemical information of elements. Without it, chemistry would be a confusing jumble of random observations to us. We can predict a lot about the chemical behavior of an element if we know where it is on the periodic table. It also can be used to predict chemical properties of undiscovered or newly synthesized elements. Here is the periodic table. I think all of you seen this picture of periodic table before. The periodic table is arranged into columns which we call groups. We have group 1 and 2 at the extreme left. Then we have this big block which called transition elements. After that we have groups 13 to 17 at the right of the periodic table. And finally group 18 which consists of noble gases. But why it is called periodic table? The word periodic means occurring at regular intervals. In periodic table, elements with similar properties occur at regular intervals. For example, group 1 consists of highly reactive metals such as lithium, sodium, potassium. All the elements of this group shows metal characteristics. On the other side, group 17 consists of highly reactive nonmetals such as fluorine, chlorine, bromine, iodine. All the elements of group 17 shows the characteristics of nonmetals. All the elements in a group have similar chemical properties. We will know more about this modern periodic table, but before that we are going to look at the history or background of periodic table. Think about that. Why do we need a periodic table? 118 elements had been identified till today. Since there are many elements, the goal of periodic table was to classify or group the elements together. Many scientists have given their tireless effort to establish the present form of periodic table. The major contributions for it by Anthony Lavoisier, Johann de Dobereiner, John Newlands, Dimitri Mandeleev, and Henry Moseley. At first, let's know about the classification of elements as metals and nonmetals. Anthony Lavoisier was the first person to attempt to sort elements into groups. His classification contained only 33 elements classified as metals and nonmetals. This classification based on the chemical properties of the elements. Chemical properties means how an element reacts with other elements and form compounds. As Lavoisier's description only classified elements as metals and nonmetals, it lacked completeness. But it formed the basis for the modern list of elements. But the defect in this classification was that he had no place for metalloids, which were discovered later. The metalloid means the elements which have some properties like metals and some properties like nonmetals. Next, we are going to look at the work of Dobereiner. Johann Wolfgang Dobereiner attempted to sort the elements in an order which consisted of triads. Dobereiner's triads were groups of three elements in order of increasing atomic masses with similar properties. He stated that the average of the atomic masses of the first and third element in a triads would be approximately equal to the atomic mass of the second element in that triads. And this is stated as law of triads. Understand some examples. The first example is lithium, sodium, and potassium. For this group, if we arrange the elements in order of increasing atomic masses like this, then the average of lithium and potassium is equal to that of the middle element sodium, which is 23. Here are two more triads that follow the same rule, but Dobereiner could identify only three triads from the elements discovered that time. Only 33 elements had been discovered at that time, and this is the limitation of the law of triads. Next, we are going to look at the work of Newlands. John Newlands arranged the elements in order of increasing atomic weight, like that. He observed that every eighth element reacts in a similar way. If lithium is the first element, then sodium is the eighth one. And Newland found the first and eighth element have similar chemical properties. Similarly, second and ninth element have similar chemical properties. And he stated this fact as the law of octaves. Look at the tabular form of Newlands, which is given by Newland. The word octaves inspired by music. Newland was a music lover. One day he observed the notes on music and he found the eight notes is the repetition of the first notes. Do, re, mi, fa, sol, la, ti, do, अथवा सा रे गा मा पा धा नि सा. After ni, again sa. The eighth note is the repetition of the first notes. Like that, if we arrange the elements in order of increasing mass, then we can observe this repetition. If we take lithium as the first element, after 7, sodium is the eighth one. And the properties of lithium and sodium is quite similar. And if we take sodium as 1, then the eighth one is potassium, and the chemical properties of sodium and potassium almost are similar. We can do the same thing with the beryllium, magnesium and calcium. These three elements also react in a similar way. From this observation, he stated the fact as a law: when the elements are arranged in order of increasing atomic masses, the properties of eighth elements are the repetition of the properties of the first element. And this is known as law of octaves. But this law of octaves have some problems. Look at the table carefully. It was applicable to only higher, lighter elements having atomic masses after calcium. After calcium, this law does not follow. The next one. Later on, several new elements were discovered whose properties did not fit into the law of octaves. The next one. Some similar elements have been separated from one another, while some dissimilar elements have been placed in the same column. For example, iron resembles cobalt and nickel, but has been placed far away from these elements. And again, similarly, cobalt and nickel do not resemble with halogens chlorine, fluorine, bromine, but have been placed in the same column. The next issue was when noble gases were discovered, the properties of the eighth element were no longer similar to the first one. Next we go for Mandeleev's periodic law. Dmitri Mandeleev worked with only 63 elements. He was looking at the relation between atomic mass of elements and their physical and chemical properties. What is physical properties? Density, melting point, and boiling point are physical properties of an element. And what is chemical properties? Chemical properties are how an element reacts with other elements. He observed how an element reacts with hydrogen and oxygen. He chose hydrogen and oxygen since hydrogen and oxygen are very reactive and form compounds with other elements. If we take sodium as an example, sodium reacts with hydrogen and form sodium hydride. And the formula of sodium hydride is NaH. And sodium reacts with oxygen and form Na2O. Similarly, potassium reacts with hydrogen and form potassium hydride with the similar formula, and potassium reacts with oxygen and form potassium oxide. If we represent the element with R, then the general formula of these hydride and oxides are RH and R2O. That means sodium and potassium have similar chemical properties. They form similar chemical compounds with elements. That's why they can be grouped together. Mandeleev used the formulae of oxides and hydrides to group the elements together. Mandeleev observed the repetition in the physical and chemical properties of elements. He arranged the elements in a table like that. The formula of the oxide and hydroxide formed by the element was the basis for the grouping. For group 1, the formula of oxides and hydroxides are RO and RH. R2, there is a mistake. This will be R2O and RH, and all group 1 elements form compound with oxygen and hydrogen with this formula, and all group 2 elements are formed oxides and hydroxide with this formula, and all group 3 elements are form the compound oxide and hydride with this formula, and so on. So Mandeleev stated that the physical and chemical properties of elements are a periodic function of their atomic masses, and this law is known as Mandeleev's periodic law. Now let's go for knowing some characteristics of Mandeleev periodic table. Mandeleev classified elements in the increasing order of their atomic masses and similarities in their properties. The formula of oxides and hydroxide formed by the elements was also the basis for the classification of the elements. Elements were arranged in order of their increasing atomic weights in horizontal rows, which is called periods, and elements were arranged in vertical columns according to their resemblance in properties called groups. The periodic table had 8 groups and 6 periods. Each period, 4th, 5th and 6th period contains 2 series. The group 1 to 7 had 2 subgroups called A subgroups and B subgroup. Group 8 have 3 elements in a row. Since only 63 elements were known at that time, he had left gaps for the undiscovered elements. And he also predicted the characteristics of that elements, and her prediction was correct. That's the end of our today's class.